So here we're gonna talk about optical instruments, integrated science with integrated curriculum, and ICSTEM approach by Aisyah, Nurul, Hasanah, Purnama. So what is optical instruments? An optical instrument is a device that processes light waves either to enhance an image for viewing or to analyze and determine the characteristic properties. So in this video, we're gonna talk about first lens, then eye, camera, microscope, and telescope. So let's begin with the lens. So lens. The most familiar and widely used optical device is the lens. A lens is an optical system with two refracting surfaces. The simplest lens has two spherical surfaces. So lens is the important part of the microscope or telescope or other sources. So the kinds of lenses have two kinds, is convex lens and concave lens. So the properties of the lenses. So here we see the rays diagram of the concave lens and the convex lens. So when a beam of rays parallel to the axis passes through the lens, the rays converge to a point and form a real image at that point. So we can see that the concave lens has the focal point in front of the lens, while the convex lens, the focal point is behind the lens. The next is lens equation. So to understand the derivation of the formula, we must look at the space and length. So here shows the existence of room 1, 2, 3, and 4 in convex lens and concave lens. The object room of the convex lens is room 1, 2, 3 is in front of the lens, meanwhile the room 4 is behind the lens. Opposite with the object room, the image room of the convex lens is now room number 4 is in front of the lens, meanwhile the room number 1, 2, 3 for the image room is behind the lens. And for the concave lens is the opposite of the convex lens, you can see. And here is the derivation of the lens formula. We can see that the magnification of the lens is HI over HO equals to SI over the SO. So next is the eyes. The eye is a sensory organ that functions much like a camera. So it focuses light on a light-sensitive surface of the retina using lens and an aperture or opening, the pupil, whose size can be adjusted to change the amount of entering lights. So here is the part of human eyes. You can see the image here. Where is the lens? Where is the pupil? Where is the retina? Previously, we talked about the human eyes. Now, let's talk about the animal eye lens. So how the animals see? So insects have compound eyes, compound of 100,000 of light-sensing columns called ommatidia. So in addition, the presence of many light-sensitive columns makes species with compound eyes particularly good at detecting movement, just like insects, crustaceans, and some mollusks and annelids. And several organisms have eyes that operate according to the principle of mirror optics. Tapetum is an important structure of the eye that improves the night vision of numerous terrestrial animals, just like cats and tigers. They can see their eyes shine bright and at the night. And next we talk about the eye problem. So there are several eye problems just like myopia, hyperopia, presbyopia, astigmatism, color blindness. So myopia is when the focal point falls in front of the retina. Hyperopia is when the focal point falls behind the retina or the lens is too big. Presbyopia is the reduced accumulation in old age, so that the point near the eye becomes closer. Astigmatism is caused by an out-of-run cornea or lens, so we can't see things clearly. And color blindness is when a person unable to distinguish colors from others. So a person who has myopia, heteropia, presbyopia is usually use glasses or contact lens that can help them the light to focus in the right place within the eye and make image sharp again. So the most common eye problems are myopia and hyperopia. So this is the ray diagram of myopia and hyperopia. So you can see if the focal point of myopia eye is falls in front of the retina. So someone who has myopia needs a contact lens for correction and see things more clearly. And this is for the hyperopia eye. So the focal point is behind the retina, and someone who has hyperopia needs a contact lens to see something clearly. Camera. The camera makes a small image of an object and records the image on film. The basic elements of a camera are light tight box, a converging lens, a shutter to open the lens for a prescribed length of time, and a light-sensitive recording medium. So we can see the camera right diagram. So the object to be photographed here and use the contact lens. Here is the focal point of the camera. So the image is here is the real and inverted image. So the camera has some functions with the eye. We just talk about that briefly. So the eye focuses image in the retina, although the image is upside down. The brain processes it so that we can perceive it the correct way up. The operation of the eye acts very much like an old-fashioned film-loaded camera. So camera focus similar to the eye. You can see here. Here is the image, and the camera resulted an inverted image, just like the eye. And some parts of the camera have similar functions with the eye parts, just like film, same as the retina, diaphragm is same as iris, aperture same as the pupil, and lens same as the lens in our eyes. So the example of the technological of the camera is the pinhole camera. So a pinhole camera is a simple photographic camera where the lens is substituted by a tiny hole called pinhole. So we can make it by ourselves by using a cardboard or other sources with a pen. Next is microscope. Microscope is an instrument used to see objects that are too small to be seen by the naked eye. So microscope consists of an arrangement of two convex lenses. The convex lens near object is called the objective lens. The convex lens near the eye is called the ocular lens. The focal length of the ocular lens is longer than the objective lens. So the magnification of the microscope is equals to H accent objective over H objective equals to S accent objective over S objective. Microscope and cells. So we can see cells with microscope. So microscope does two things that allow cells and details within them to be seen by the human eye. They provide the ability to see great detail, which allows the viewers to magnify the image of interest. The property that allows detail to be seen is called resolution. Resolution is the minimum distance two objects can be apart and still be seen as two objects. So we can see the small things with microscope. So there are two basic types of microscope, light microscope and electron microscope. We usually use light microscope using a light from the sun or the lamp. And the last is Telescope. Telescope is used to view large objects at large distance. Telescope is similar to that of a compound microscope in both instruments. The image formed by an objective is viewed through an eyepiece. Telescope use a curved mirror, not a lens, as an objective. So, telescope have two kinds: the reflecting telescope and the refracting telescope. The reflecting telescope uses a curved mirror. So here is the equation derivation for telescope. So the magnification of telescope is m alpha equals to f objective over f ocular. And here is the ray diagram of the telescope. So here is the distant object or the alpha, objective length, eyepiece length, and here is the final image at infinity. Telescope and birds. So basically, the animal eye size have similarity with the telescope, and we compare it to human eyesight. Example, the eagles. So eagles can see clearly about 8 times as far as humans can, just like the human use a telescope to see something in far, allowing them to spot and focus on other animals about 2 miles. Meanwhile, the owl's large tube-shaped eye contain many more rods than human eyes, which allows them to be more sensitive to light and can see something clearly in the dark. And here is our project. It's called Smartphone Projector. So the smartphone projector is a charmingly lo-fi way to share your phone screen. Just place any smartphone that will fit into the cardboard box, and the lens enlarge the image by up to 8 times. And here we use a magnifying glass. And so that's it for me. Thank you.